I can make Besu teams faster, but speed is not the goal by itself. In enterprise blockchain, every recommendation still has to protect trust, security, compliance, and accountability. In this module, we'll look at where AI helps, where it can fail, and how to use it responsibly. Before we focus on AI, anchor it in what you've already built: Besu models, enterprise architecture, smart contracts, and operational risk. I should extend those capabilities carefully. It can automate insight and support action, but it must not weaken governance, security, compliance, or human control. AI is valuable in Besu environments because it can reduce friction across the lifecycle. It can draft documentation, generate tests, summarize logs, and surface unusual infrastructure behavior faster than a team working manually. But enterprise blockchain is not a place for unchecked automation. Contracts, keys, and transactions may represent real assets or regulated processes. AI output should feed into review, testing, audit trails, and governance. The goal is responsible augmentation, not replacement of trust controls. Across the Besu development lifecycle, think of AI as an accelerator, not an owner. It can help turn requirements into Solidity drafts, suggest interfaces, and create integration examples. It can also generate unit tests, negative tests, and edge cases developers may miss. The same support applies to API docs, deployment notes, and maintenance explanations. Before anything becomes trusted application code, it still needs human review, static analysis, and CI/CD validation. For smart contract work, treat AI as a drafting partner rather than an autonomous engineer. Start with narrow prompts, such as a modifier, an event set, or Foundry tests for role-based minting edge cases. Then ask for expected paths, unauthorized callers, boundary values, and state change checks. Map each suggestion back to requirements and threat models. Finally, use linters, static analyzers, coverage, and peer review before accepting the code. In enterprise Besu work, AI can accelerate coding and configuration, but responsibility stays with the team. Every AI-assisted change needs a named developer who accepts ownership. High-risk areas, including smart contracts, permissioning rules, private keys, and consensus settings, require security review. Automated gates should run tests, static analysis, dependency scans, and policy checks before deployment. When governance requires it, keep audit records so production changes remain traceable and defensible. Besu gives you many operational signals: transaction volume, gas use, block timing, peer changes, RPC activity, and node resource behavior. AI monitoring can turn those streams into a learned baseline of normal operation. Instead of waiting for a fixed threshold, it can detect unusual combinations, such as slower blocks, failed calls, and peer churn happening together. It does not replace Prometheus, Grafana, logs, or traces. It adds context, prioritizes alerts, and helps teams respond faster. Anomaly detection works best when the model understands what normal looks like. In a permission network, expected participants, contract methods, work hours, and business cycles are often known. The model compares live activity against those baselines and flags spikes, repeated failures, unauthorized calls, unusual gas usage, or after-hours behavior. The point is not to automatically shut systems down. It is to surface risk early with enough context for investigators to decide the right action. In operations, the useful signal is rarely a single metric. A CPU spike, peer drop-off, sync lag, and rising RPC latency may each seem manageable on their own. Together, they may point to a node falling behind or a network path degrading. AI helps by correlating those symptoms with transaction load and application events, then ranking alerts by operational impact. That supports earlier intervention, before instability becomes an outage or a consistency problem. An AI alert should never be treated as the response by itself. Route the anomaly into the normal incident workflow first, then validate it with human review, especially before actions that affect availability, permissions, or production traffic. Triage determines severity and ownership. Escalation brings in the right responders. Runbooks guide common cases such as node lag, API abuse, or transaction failure spikes. After resolution, the review should improve model tuning, thresholds, and escalation rules. AI governance means treating model output as advice that requires control, not as authority. In Besu environments, hallucinated code can weaken node configuration, risky recommendations can violate policy, and biased data can distort anomaly detection. The harder questions are often about auditability and accountability. Who approved the change, why it was trusted, and what evidence supports it. A practical approach is to identify the AI risk, map the system impact, and apply the right control, such as review, testing, logging, or policy gating. Treat every AI prompt like a potential data export. Never paste private keys, seed phrases, credentials, production secrets, or unapproved transaction details. Be careful with contract logic, identities, logs, regulated records, and compliance evidence. Use only approved AI platforms with access controls, retention rules, and audit logging. Before sharing anything, minimize the data, redact sensitive fields, anonymize examples, and store prompts securely for review. In enterprise blockchain, an AI recommendation is not enough on its own. Teams need to know what evidence was used, which model version produced the output, who reviewed it, and why the final action was accepted, rejected, or escalated. That record is the bridge between automation and accountability. For high-risk decisions, favor interpretable signals and documented reasoning. If auditors, regulators, or governance boards cannot reconstruct the decision, the control is not mature enough. Looking ahead, enterprise blockchain may become a trust layer for AI-driven systems. A Besu network can anchor hashes of model outputs, datasets, attestations, and decisions without storing sensitive content directly. Decentralized identity can help prove which person, system, or agent acted and under what authority. Provenance creates a traceable history of change. The key principle is control. Autonomous agents may execute workflows, but only within explicit policies, permissions, auditability, and human oversight. AI can accelerate Besu development and operations, but only as a controlled assistant. Use it for drafting, testing, documentation, monitoring, and analysis while keeping humans accountable. Protect sensitive data and keys, require review and audit trails, and carry these practices into Module 5's end-to-end solution design.